So finally we realize that we need numbers to acknowledgements also, isn't it? But how to number them, we have to find out. There are two ways we can number. One model is like whenever you have a frame with some sequence number, let's say 0, then we are going to send ACK with same number 0. That is method number 1. Second method, for frame number 1 comma 0, send ACK 1. So this means that we are currently acknowledging the frame which we got. Here we are saying that we got 0 and now the next expected number is 1. Understand? Now there is no difference, we can use anything, but you can understand the this purpose why we do this one. It's straightforward, right? Rather than this one, if why we use this one, I will tell you when we study sliding window protocols. That means go back and SR. At this moment you don't understand the difference, but let me use this one so that you get habituated. But anything is okay at this moment. Okay, now let's begin. At 9 o'clock what happens is frame number 1 is going to come, right? Assume that let's say it hits at 10 o'clock, frame number 1 comma sequence number 0. Then expected sequence number 0, then exactly same thing is happening. That means it's successful arrival. We send it to network layer and we make it 1. That means we are expecting 1. That is the same thing we convey to receiver, sorry, sender. So that's why we are going to send a frame called control frame ACK1, right? Now so far it's good. At sender side, if you see, since time over is exactly for 2 hours, 9 o'clock we send a packet and we did not get the acknowledgement. Then at 11 o'clock we are going to send another packet, right? We know that. Let's say assume that it hits at 12 o'clock, but we know that it's same again, F1 comma 0. Now at receiver side, whenever this event occurs, your receiver will see like this, F1 comma 0. 0 and 1 different. I am expecting 1 and I got 0. That means now I have to acknowledge it. So that means, my dear sender, I am actually expecting 1, ACK1. So ACK1 will be sent again. So assume that let's say it is going a little bit quick. Now we will see at sender side, 12 o'clock we did not discuss, right? 11 o'clock we sent a frame and 12 o'clock we got acknowledgement, and we might think wrongly and we may send one more frame, right? What is that? Because ACK1, that means successful receival. Then immediately we make it 1 and we say that F1 finally got received. Yes, it is true. That's why we got acknowledgement, right? 100% true. Now F2 will be sent here. What is the acknowledgement number? Sorry, what is the sequence number? Sequence number will be definitely 1, F2 comma 1. It will slowly will come here and assume that it will disappear here. Still no problem, we'll see. At 1 o'clock one more event has been occurred, right? What is that? ACK1. Now your sender thinks like this. What is the acknowledgement? 1, right? What is the sequence number 1? Whenever these two match, actually they should not match. If they match, then definitely it's a wrong acknowledgement. That's why immediately it will send the packet again. So what was the sequence number? Sequence number 1. So again one more frame will be sent. That means same frame F2 with 1, right? So currently, you know one thing, right? We are having F2 with us. That's why F2 will be sent. Now eventually it will go to that receiver at after some time whenever it is received. So your receiver is going to send acknowledgement suitably. What is that? Whenever F2 1 comes here, 1 and 1 matches, then this will become 0. Then next expected acknowledgement is 0, ACK 0, right? So ACK 0 will be sent. In that way, these two, sender and receiver, are going to communicate in this one, and we solve that problem like which we had initially, right? Now let's summarize complete stop and wait protocol. In stop and wait protocol ARQ, we have timers. Okay. Second thing, we have sequence numbers, we have acknowledgements. These are the three things. First of all, sender sends a frame and timer will begin. Now after, if really before getting the acknowledgement, if timer gets timeout, then you have to retransmit that frame. Okay. Second thing, if it is successfully transmitted, then your receiver is going to send the acknowledgement. If that acknowledgement is successfully received before timer times out, then your sender is going to your sender is going to take another frame, second frame, and he is going to change the sequence number. Now again same process will go on. Okay, so this is about stop and wait protocol. Now we'll see some possible scenarios of stop and wait protocol, and we try to understand how these acknowledgement numbers and frame numbers are going to be decided. So let's see the picture and try to fill these boxes. Okay, initially let's say current sequence number is 0 at sender side and expected sequence number at receiver side is 0. That is initialization. Otherwise we can start with ones also, not a problem. Now first of all, sender is sending frame number 1. These are the frames at network side. Now frame 1 comma dash, we are going to send sequence number dash current sequence number 0. Right, slowly. It's been received. When it's received, then we are going to send acknowledgement for that. What should be the acknowledgement? ACK1, right? So then see, successfully it's been received. Now we are sending again another frame, right? F2. We are sending F2 means what? Timeout did not occur, right? Before timeout, we got write acknowledgement. Now remember one thing, write acknowledgements always that sequence number will be opposite to current sequence number. That's why 0 1 quite opposite, right? Now whenever this event occurs, what is that? Arrival of acknowledgement and it is successful, then we have to change it to 1. That means now next sequence number is 1 and we are going to do what? We are going to take the another frame F2. So here it is F2 and what is the sequence number? 1. So when F2 comma 1 is sent, since that event has been occurred, that means we got F2 here, we are going to send acknowledgement, but unfortunately it got missed, of course. But what should be the acknowledgement here in this one? Since, did you remember here, when F1 is arrived, then we have to change this expected sequence number to 1, correct? That's why ACK1. Now similarly here, when F2 comma 1 arrives, since it is successful again, because see 1 and 0 again same thing. So F2 comma 1 and what is our expected sequence number? 1. So whenever these two matches, it's successful here. Try to understand. Current sequence number always should be opposite to the acknowledgement number, then it is successful. This side, sequence number of the frame should match with expected sequence number. Yes, 1 and 1 matches. Then successful. Then we are going to send ACK 2. Actually 2 is not possible. Sequence numbers are 0 and 1. They are enough, right? That's why we are going to send 0 again. So ACK 0. We don't require 2 unnecessary, right? So because already when you use ACK 0, you don't get any confusion. What's the reason? Already whoever 0 is already used by someone, but it's successfully sent. That's why there will not be any problem here. Currently we are not using 0. We are using now 1, correct? That's why sender doesn't have any problem with 0. That's why when we send ACK 0, there will be no problem. But it's lost. When it is lost, then what happens? Definitely timer should time out, correct? So that's why here, let's say we assume that timer times out, then we are going to send the same packet. At this moment, see, same story, right? F2 comma 1. But in this period, we did not get any new event. That's why same packet has to be sent, right? F2 comma 1, I can say. So F2, same frame, whatever the frame we have, and what is the sequence number we have to send? 1. Now slowly it will receive here. If it receives, then remaining story will be, we know that. Example, let's complete here. If F2 comma 1 is arrived, this 1 will be compared with this one, right? 1 and 1 matches. So simply toggle it. 0. That means next sequence number we are expecting is 0. Here you send ACK dash 0. So this is the way your stop and wait protocol works and negotiation takes place. Now we'll see this one. Current is 0, expected is 0. Let's begin. Frame number 1 with dash sequence number is started 0, but it's lost. But send receiver doesn't know that. So he will be simply waiting for the frame. Then what happens after some time? Again he got, so this is the first time he got a successful event, right? So this packet lost everything, he cannot understand. So receiver at this moment will respond, and what should be this box and this box? We will see, because it's coming from sender and maybe, so he did not get acknowledgement for F1. That's the reason he is going to send it again. There is no other way we can understand it. Really F1 comma 0 is received, then he would have got acknowledgement. So far this sender did not get any acknowledgement, means what? Definitely he is sending same frame number 1. What should be the sequence number again? 0. Same thing. Now here at this moment, so we can say that one successful event has been occurred, that is arrival of the frame, and that is sequence number 0 and 0 matches, toggle it, then ACK this one expected ACK1, right? Now F1 will be sent to the network layer, ACK1 slowly will receive here. By this time here one more, why, what is this one more arrow like this? Maybe timer times out, then he's sending again one more frame. What could be the frame here? Definitely frame number 1 is received, but he did not get acknowledgement. You see, this is delayed acknowledgement. So before getting this acknowledgement, then sender is sending another frame, means definitely that should be same frame, right? F1 comma 0. So F1 0 will be sent. In that way you can understand about this scenario, right? So this is about stop and wait protocol. Now we are going to see the disadvantages of this stop and wait protocol. Generally, in what situation we can use this stop and wait, and what is the major problem with this stop and wait, we are going to see. Let's try to understand the drawback of stop and wait protocol. Let's begin with that. Example, this is sender and this is receiver, and various frames are F1, F2, F3, so on. So we know that sender first sends frame number 1, right? Now after that receiver is going to send acknowledgement for frame number 1. So before that we never send frame number 2. That means once we send the entire frame, then we are going to wait for acknowledgement. There is a waiting, right? Just note it down. Now after that we send F2, then we wait for acknowledgement. So what can happen is, in the worst case, so that waiting will be very large. We'll see with one numerical example. Let's say sender is sending some frames of size, some fixed size, whatever it is, but the transmission time of each frame is 1 hour. So that means, so there may be some bits in this frame number 1. To keep all the bits onto the line, it takes exactly 1 hour. Maybe first bit takes 0 time, but last bit definitely feel 1 hour of duration. That means the time gap between the arrival of the first bit and the arrival of the last bit onto the frame is 1 hour. That is what transmission time. Now assume that there is a propagation delay of 10 hours. So that means, so the first bit is going to come immediately onto the line almost with 0 time. There may be negligible time for that, but after 0 time, I can assume like 0, then this first bit immediately will start running, right? How much time it will take to reach receiver? 10 hours. So finally, so when t equal to, let's begin with t value 0. Initially time is 0 when we started this protocol. Then at t equal to 10, then first bit of that frame which we sent is going to be received by receiver, right? But we can't process that bit. We have to process entire frame. That's why we can't send acknowledgement immediately. So we will be waiting for entire frame, but when this entire frame will come, so that is exactly equal to when the last bit will come. So last bit will come onto the road after 1 hour, and the propagation delay is 10 hours. Then that last bit is going to feel 11 hour delay, right? That means at 11th t value 11, so last bit is going to come. Then this receiver is going to process that frame. Assume that processing time is negligible, 0. And immediately, let's say receiver transmits acknowledgement onto the line. So usually ACK kind of frames will have very less size. So transmission time of ACK will be negligible. That means it might take 0 time, almost 0. That's why we don't worry about it, right? So if that is the case, immediately that ACK starts running, then after how many hours it will reach that sender? 10 hours. So finally what I want to say is, you started t value 0 at t value 0, then 11 plus 10 after t value 21 at t value 21 otherwise. So finally you got acknowledgement, right? Now what I want to say is, in this entire 21 hours if you observe in stop and wait protocol, effectively how many hours you used for transmission? Exactly 1 hour, right? So 1 hour you were busy, but remaining 20 hours you were waiting, isn't it? So that's why the link utilization here is exactly 1 out of 21. Link utilization is nothing but what is the fraction of time you are using the link. You are capable of sending 21 hours maybe, but out of that only 1 hour you spent because of this waiting, right? So that's why that is a drawback of this stop and wait protocol, right? So you can see that drawback in a big way if the propagation delay is very long, like if this is 100 hours and transmission time is very negligible, that means it takes only 10 seconds. So then you can see it in a very big way, right? So after 10 seconds, your entire frame is now transmitted. Now you are free. But after 10th second onwards, so you are free, but 100 hours of time, so your frames are going to travel. After that they will come. Then I can say that 200 hours of time, so you are waiting, right? Almost 200 hours. That is a problem. For very long propagation delay and very less transmission time, then definitely stop and wait is not good, right? So how to avoid that? To avoid that, first of all, you should understand the problem with stop and wait. In stop and wait, what happened is, so you unnecessarily waited for acknowledgement, right? Don't do that. So what we do here in the second modification, we fix some window size. That means we say that we have an imaginary window and that size is, let's say, 5. So that means rather than sending one frame, we keep on sending 5 frames first of all without waiting for the acknowledgement. So after sending these 5 frames, then we start waiting for the acknowledgement of each and everything one by one. So this method is called sliding window method. So these protocols which uses this concept called sliding window are called sliding window protocols. There are 2 variations we are going to study. First one is go back N protocol, which is very popular. Second one, selective repeat protocol, SR protocol. So we'll see one by one. In go back N, so we will be maintaining a window size of N, and we will see the remaining story how this go back N is going to work everything. Okay.